This is another in my occasional series about how to apply incidents in the real world to how we design our software to be more reliable. Now, honestly, when I think about reliability, I think about Taylor Swift. So what do I mean by that? You may remember the Ticketmaster debacle where they tried to have a bunch of tickets go out for Taylor Swift, and then the site just went down for hours. And obviously all the Taylor Swift fans were, it was the end of their lives, that they couldn't get this ticket and so forth. Understandable. And, the Ticketmaster basically said that it was experiencing unprecedented demand. Now, at some level, that's nonsense, right? Because they kind of know what they're going to expect. And, you can always load test your systems to a particular level that is well, beyond what you're expecting to take in with any concert. And so, maybe it was unprecedented demand, but it also definitely represents a failure of imagination in how much you load test these systems. But let's not worry about the testing. There's not a heck of a lot that we can learn from that other than, test to higher load than you expect to take, which, they would have said that they do even beforehand. What I like to talk about here is queuing. So I used to sit in meeting after meeting after meeting at AWS where we'd go through outages and we'd hear about, I got way more demand than I was expecting to deal with, and so my service fell over. Now, the lesson here is that the first job of a service is to protect itself. So the way you do that is by putting a queue in front of your service where you say, I know I can handle this many requests, 10,000 per second, 50,000 per second, 500 per second. And I'm not going to take any more than that. The rest of them either are going to get an error or they're going to get queued. As a result, and they did a little bit of that, but not enough, clearly, because the site did go down. And the benefit from doing that is both that you're protecting yourself and that a portion of the demand is getting served. And the way I think about this is, something you can take away is that you should build escalators, not elevators. Think about it. When an escalator fails, it turns into a staircase. You can walk up a staircase maybe a little bit more slowly, but you can do it. When an elevator fails, it turns into a shaft. And it's not really worth much of anything at that point. And so you might say elevators are better than escalators because they're faster and they can, and so forth. But I think we've all been in elevators during the lunchtime rush or the 5 o'clock or 6 o'clock, whenever everyone's leaving rush. They don't tolerate variability in demand all that well. An escalator kind of does, right? You go up at a particular pace. You can see it, you can see when you get on, you can see when to go off. It's intrinsically like a queue, right? It takes a certain amount of demand and it does it in a consistent way. And so that's at least what I took away from this thing. Less about capacity planning and more about what do you do when capacity planning fails, which things do happen, right?